Okay, let's get started with 6.5, the last section in Chapter 6. And we're going to do trig form of a complex number. So, we're going back to our imaginary and real axes, the complex number plane. So this is going to be a little obnoxious because we've been dealing with the vector form where we have I representing horizontal and j representing vertical vectors. Okay, and this is in the real number plane. When we go to the imaginary number plane, remember that you have your regular numbers, 1, 2, 3 along the real axis, and then you have the i's up and down the vertical axis. So this is 1i and 2i and 3i as we go up and down. So the I switches direction, switches axes if we switch from the real to the complex plane. All right, so absolute value of a complex number, we're going to have this, and that's just the magnitude of a vector. Same thing here for the absolute value of a complex number. We're just finding the distance here. So again, this is the distance formula, and same thing as the Pythagorean theorem that we've been working with all year long. So let's get started here. Plot z, and we use z instead of v. V for vectors, z for the complex numbers when we're graphing it. So first things first, let's plot this. -2 will go left 2, and 5i will go up 5, and there we go. And we're going to go from there to there, starting at the origin, and then we'll just find its absolute value by using the distance formula. So -2 squared plus 5 squared, and we get 4 plus 25 is root 29. So the absolute value is root 29, and that's the look of the plot. All right, so just that easy on exercise 9. Okay, so the trig form of a complex number. All right, so what we've got here is we've been, just like in vector form, think back to vectors. We either have the I comma j component form, or we're giving a magnitude and an angle. Same thing goes here for the complex numbers. We're going to say trig form. The trig form is, where are we? Right here, where r is our hypotenuse, r is our distance, r is the magnitude, however you want to think about it, and theta is the angle. So same rules still apply. Magnitude, we're using the distance formula. For complex numbers, we're using the letter r. And to find the angle, we'll use the tangent of the height divided by the width, right? The y over the x values, okay? All right. The number r is the modulus, okay? We use that phrase. And theta is the argument of z, all right? So we've got the modulus and the argument. Plural of modulus is moduli. Okay, so if we're finding multiple r's, then we'll have moduli. Multiple arguments, okay, just normal plural on that one. Okay, this is also called polar form. So when we say find it in polar form, that's the same as trig form here. All right, so we've got our complex number with our real and our imaginary part. Let's find it in trig form. So trig form needs an r, so we'll start with that. Square root of -2 squared plus -2 root 3 squared, which is square root of 4, plus 4 times 3, which is 12, which is the square root of 16, and so we get 4. All right, and then theta is going to be our inverse tangent of -2 root 3 over -2. And so we can use our calculators on this one. And let's make sure we're in degrees. We've been in degrees this whole chapter, so we'll be consistent with it. If you're looking in the book for the explanations in a lot of these problems, they're in radians, but either one really going to be fine. So we're in degrees here, and so we'll do the inverse tangent of 2 root 3. Close our parentheses, divided by 2. Notice that the negatives cancel out, so I'm not going to put those in. All right, we get 60 degrees here. And be careful, though, because 60 is not the correct answer. And the reason why is that -2 and -2 root 3, which root 3 is about 1, so we're down here somewhere. Okay, that's in quadrant 3. Okay, so 60 degrees is the reference angle, but the actual angle is 180 plus that, so 240 degrees is what we want to go with for our theta. So be careful about what quadrant you're in. Okay, think about the signs of your real and imaginary numbers in these. So we've got an answer here. Our answer is 4 cosine 240 plus I sine 240. That's the form for polar or trig form. All right. Now, that's the extended answer. We're going to use a shortcut a lot of time. Instead of writing cos and I sine, because you'll notice this angle is always going to be the same, we're just going to write C for cosine and then IS for sine. So 4 CIS 240 is the same as saying 4 cosine of 240 plus I sine of 240. Okay, just a shorthand, a little easier to write that way. You're up. 17. See if you can do the same thing. Find the trig form of 1 minus root 3i. Okay, number 3. Now we're going to go write the complex number, okay, given the trig form. So we're going to go backwards on this one. This one's pretty straightforward. Okay, so our r is the square root of 8, and we want to figure out our, we know our angle is pi over 3. We want to figure out the real and the imaginary number. So all we're going to do is, what is the cosine of negative pi over 3? All right, negative pi over 3 is on your unit circle. We go to that, we go down a pi over 3, and we get, I'm looking at this point down here on the unit circle, and that is 1/2 comma negative root 3 over 2. Okay, so I can just plug those in for my cosines. 1/2, root 8 still on the outside, plus I, and then the sine of negative pi over 3 would be negative root 3 over 2. Okay, just pulling that right off the unit circle. All right, we'll distribute the square root of 8. Square root of 8 is 2 root 2, okay, times the 1/2. And so the 2's will cancel there, and we end up with just root 2. And then we've got minus root 3i over 2. And here again, the 2's would cancel, and root 2 times root 3 is root 6i. So our real number is root 2. Our imaginary number is negative root 6. Same thing on 35. Figure out the cosine and the sine of negative 30 degrees, and then distribute in root 48. Okay, now we're going to multiply and divide these complex numbers, and this is very straightforward if you can get yourself into trig form. So, step 1 on any of these problems is get yourself into trig form, okay, r CIS theta. And then the rule is, if you're multiplying two different complex numbers, okay, you multiply the moduli, you multiply the r's, and you add the angles, you add the arguments. Okay, for division, divide the moduli, subtract the arguments. All right. Let's give it a shot. So we already are in trig form here. This is 2 CIS 2 pi over 3. This is 8 CIS 11 pi over 6. So I'm going to multiply the 2 and the 8. 2 times 8 is 16. All right, so that's my r. And then I'm going to add the angles. 2 pi over 3 plus 11 pi over 6. Let's get a common denominator. 6, and that turns into a 4. 4 plus 11 is 15 pi over 6. All right, that is bigger than 2 pi over 6, so we're going to bring it around. Or, I'm sorry, it's bigger than 2 pi. Let's subtract a 2 pi out of there and get 3 pi over 6, which is equal to pi over 2. And so we have, for our final answer, 16 CIS of pi over 2. All right, so now we want to expand this out to get the complex form. Okay, so we're going to say 16 cosine of pi over 2, what does that turn into? Plus I sine of pi over 2, what's that turn into? The cosine of 90 degrees is 0. The sine of 90 degrees is 1. So our answer here is 16i. Okay? You could write 0 plus 16i also. Same thing, 16i. All right, so see if you can multiply these two complex numbers. All right, and then let's find the quotient. So same rules apply. We're going to go moduli division. 24 divided by 8 gives us 3. That's our r. And we're going to subtract. 300 minus 75 equals 225. And that's our theta. So we've got 3 CIS 225. All right, that's in trig form. If we were asked to turn this into complex form, 3 cosine of 225 plus I sine 225. I'm going to look at my unit circle. 225 is on there. 225 is down here with a negative root 2 over 2 and a negative root 2 over 2. So I've got 3 negative root 2 over 2 minus root 2 over 2 I. And so my final answer here is going to be negative 3 root 2 over 2 minus 3 root 2 over 2 I for my complex number. All right, trig form, complex form. Your turn, problem 53. Okay, so now let's add in some exponents here. All right, so just like with multiplying and dividing, we had some rules for the moduli and the arguments. The same rules apply here for the powers. Okay, so the rule is right here. Okay, and what we're going to do here is z to the n. Okay, we're going to take our trig form and raise it to that power. And the shortcut then becomes take the modulus and raise it, and take the arguments and multiply them. Okay, so it's like one step down for the arguments. Instead of squaring, we're multiplying. And just in your book, there's a nice note on Mr. Demov, and that's what this rule is called. It's named after Abraham Demov. What a guy. All right, example 6. So we need to be in trig form first, so let's find our r. So square root of negative 1 squared plus root 3 squared is square root of 1 plus 3. Square root of 4 is 2. And tan theta equals root 3 over negative 1. Inverse tangent of root 3. And you should be able to get this off of the unit circle as well, but you can always cheat and grab this. 60 degrees. Be careful what quadrant you're in here. Your left one and your up. Okay, so 60 degrees right here gives us 120 degrees. So we've got a trig form of 2 CIS 120. All right, now our job is to raise this to the 12th power. And this is the straightforward part. So 2 to the 12th, 120 times 12. All right, so 2 to the 12th, and what's that going to be? 2 to the 12th, 4096. And 120 times 12. 12 times 12 is 144 with an extra 0. Okay. And we're going to divide some 360s out of this to get us down within one unit circle. So let's see, 1440. And how many full circles go into this? Oh, exactly 4. So we could subtract out 4 full circles and end up with 4096. Cosine of 0 plus I sine of 0. At 0 degrees, cosine is 1, and sign is 0. So 4096 is all we've got. Just a real number, no imaginaries for the 12th power of negative 1 plus root 3i. Same steps on 69. Find the 6th power of negative 1 plus I. Okay. Notice that the instructions say standard form, so that's why we're going from the polar form here, the trig form, and down here to the standard form to finish. Okay, and then we'll wrap things up here by finding the square roots. That's the last thing that we have to do. Okay, here's the rule, but I think it works out better to just follow an example here. Okay, we'll square root the moduli, and we're going to divide the roots, divide the arguments, plus 2 pi k. Okay, and we'll get into what that means in a second. All right, so find all the 6 roots of 1. So first things first, we need to put this into trig form. If it's a real number, that's pretty easy. It's just right here at 1, 0. All right, that has a radius of 1, a hypotenuse of 1, however you want to think about it. R is 1, and think about what the angle is. The angle is going to be 0. So right now we've got 1 CIS 0. Okay. Now 0 doesn't divide very well, so instead of 0, we want to use 360 instead. Okay. All right, and we're going to find the 6th roots of these. All right. So here's how we do it. We start with the R, 1, and just the 6th root of 1. Okay? And then we go CIS. We're going to go 360 divided by 6, okay, plus the 2 pi part over the 6. All right? And so here's how this is going to work out. 6 root of 1 is easy. That's just 1. Okay? But since we're finding the 6th roots, all of them, we need to find 6 answers. So 1, 2, 3, 4, 5, 6. We're going to find all the roots. All the roots are going to have the same R out front. Okay? We're going to start by going 360 divided by 6, and that's 60. So CIS of 60. All of these get 60s on them. All right, now here's where that K thing came into play. There was a K on this in the formula. What that means is we want to start by taking 2 pi, which is 360 if we're in degrees, dividing it by the roots, okay? That's 60. We're going to add this to each successive answer. So we're going to say plus 60. We're going to say plus another 60, or 120. We're going to say plus 180. We're going to say, oops, plus 240. And then finally plus 300. Okay? So our answers here turn into CIS of 120, CIS of 180, CIS of 240, CIS of 300, and CIS of 60 plus 360 is going to be 360 again, or 0. Okay? All right, so we have 6 answers. So a little trickier. On 91, you're going to have 4 answers here, so 4th roots. So same steps, though. Look at your steps here for example 7, and see if you can find the 4th roots of 16. All right, so now let's do the same thing, but with a complex number. Let's find the 3 cube roots of negative 2 plus 2i. So we're going to need this in polar form first. So r is square root of negative 2 squared plus 2 squared, which is 4 plus 4, which is square root of 8. Okay? And we're going to find the cube root of that. So the cube root of the square root of 8, that's the same as the 6th root of 8. So that's going to be our r. And we're going to have 3 answers here. So answers 1, 2, and 3. And we have 3 answers because we're finding the cube roots here. So 6th root of 8, 6th root of 8, and 6th root of 8, okay? And this is, since 8 actually is 2 cubed, we're doing the 6th root of that. We can actually cancel these and just find the square root of 2. So let's just simplify that down. Square root of 2 is our r. All right, now let's figure out our angles here. So theta is the inverse tan of 2 over negative 2. Those angles are the same, so this is going to be a 45-degree angle over here in quadrant 2, so that's going to be 135. All right, so here's what you do first. You take the 135 and divide it by 3. That gets you 45 degrees. All right, that's our starting point. CIS 45, CIS 45, CIS 45. And then we take the whole circle. We take 360 and we divide it by whatever our root is. So divided by 3, we get 120. That's what we need to add on to each successive one. So 45 plus 120, 45 plus 240. And so 45 plus 120 turns into 165. So root 2 CIS 165. And plus 240 is 295. All right? So those would be your 3 roots for negative 2 plus 2i. You're up on 97. All right, and that does it for Chapter 6. Any questions? Make sure we go over them in class. Good luck.